Welcome to solverfy.
In this question, we have two rods, AB and BC. So AB is 2 meters, and then A and C at this instance, C is 0.5 meters to the left of A, and then AB is rotating counterclockwise with angular speed of 4 radians per second, and then the angular acceleration of AB is clockwise 5 radians per second square. Okay, so we need to determine the velocity and acceleration of the slider block C at this instance. So given omega AB, so omega AB is given to be 4K. So we can determine VB. Okay, we will do velocity first. Okay, yeah. So VB is omega AB cross RAB. So this is 4K cross 2J. So you get minus 8I. VC is equal to VB plus omega BC cross RC relative to B. Okay, so from the diagram, we can tell that VC is going to move this way. Okay, because of the way because AB is rotating counterclockwise. So so we have VC negative. So we are given the 3, 4, 5 triangle here. So 3, 4, 5. Okay, this is the theta. So cosine theta is 4 over 5. Sine theta is 3 over 5. Okay. So minus VC, cosine theta I plus sine theta j is equal to minus 8I plus omega BC K cross, so position vector of C relative to B is minus 0.5I minus 2J. Okay, so cosine theta is 4 over 5, sine theta is 3 over 5. You just substitute 4 over 5I plus 3 over 5J. Okay, this is equal to minus 8I plus omega BC 2I minus 0.5J, and this is minus 8 plus 2 omega BC I minus 0.5 omega BC J. Okay, so compare components. So from the Y component, okay, we get 0.5 omega BC is equal to 0.6 BC. Okay, so that means that omega BC is 1.2 VC. Okay, and then from the X component, we have minus 0.8 VC is equal to minus 8 plus 2 omega BC, which is minus 8 plus 2 0.4 VC. Okay, and so we get 3.2 VC is 8. Okay, which means that VC is 2.5 meters per second. Okay, so this is the magnitude, and then the direction is along the 3, 4, 5 triangle. Okay, yeah. So this is VC. Okay. Now we move on to the acceleration part. Right, so the acceleration, okay, we are given that alpha AB is minus 5k, and then so we can find AB from here. So AB is equal to alpha AB cross RAB minus omega square AB, omega AB square times RAB vector. Okay, so this is minus 5k cross 2j minus 16 2j. Okay, so we get 10I minus 32j. Okay, then we use the relative acceleration equation. AC equals to AB plus alpha BC cross RC relative to B minus omega BC square RBC RC relative to B. Okay, so there's one thing I forgot to do from the previous part, which is to determine our omega BC. Okay, so omega BC is 1.2 VC. This is 3 radians per second. Okay, so we are ready. So AC, assume positive direction along the slope upward. So we have AC times 4/5 I plus 3/5 J is equal to AB, which is 10I minus 32J. Alpha BC assume positive. So, and then cross minus 0.5 I minus 2J. Okay, this is the position vector of C relative to B. And then minus 9 minus 0.5 I minus 2J. Okay, so just continue. 10I minus 32J plus minus 2 alpha BCI plus 0.5 alpha BCJ plus 4.5 I plus 18J. Okay, so group all the terms, we get 14.5 minus 2 alpha BCI plus minus 14 plus 0.5 alpha BCJ. Okay, so comparing components, so for the x component, we get this equation 0.8 AC is equal to 14.5 minus 2 alpha BC. So this is equation 1. And for the y component, we have 0.6 AC is equal to minus 14 plus 0.5 alpha BC. Okay, so if I take 1 divided by 2, then I get 4/3 is equal to 14.5 minus 2 alpha BC divided by minus 14 plus 0.5 alpha BC. Yeah, so here you can simplify to get 8 alpha BC is equal to 99.5, which gives alpha BC to be 12.4 radians per second square. Okay, so this is counterclockwise. Okay, now we have alpha BC. We can calculate AC to be 1 over 0.8, 14.5 minus 2 alpha BC, which is 12.4, and we get minus 13.0 meters per second square. Okay, so okay, and then the direction is along the slope, but down the slope. Okay, or down the channel. That's better. Okay, so this is the answer for the acceleration for block C, and that's all.